So logarithmic functions are actually the inverse of exponential functions. In pre-calculus, if you take pre-calculus, you'll learn more about inverse functions. But for now, all you really need to know is that logarithms and exponents are inverses, okay? So first, the logarithmic parent function is f of x equals log of x. And do you remember what base this is if there's no base? It is base 10. So the base 10 log function is the parent function, okay? Like I said before, a logarithmic function is the inverse of an exponential function. Using your graphing calculator, sketch the following graphs. I'm just going to sketch this for you, okay? Here's what the logarithmic function looks like. This is 1. It intercepts the x-axis at 1, and it looks like this, okay? And then we all know what an exponential function looks like. We just started graphing them. They start down here and they get exponentially bigger. Okay. So because you can only graph base 10 logs on your calculator, you will need to use inverse exponential function, then invert the values from the table to graph the logarithmic function. I will show you how to do that. It's really not that hard to do. Okay. So graph each function, do the same thing we did before. Log base 2 of x. My inverse of log base 2 of x is 2 to the x power. Okay? We have to do that first, and then we will do this guy. Okay? So let's make a table. We already did 2 to the x on the other page, so we know that its values are 0.25, 0.5, 1, 2, and 4. Okay, so all you have to do for the logarithm is switch the x and the y. So this now becomes this. Okay, we just switch them around. 0.5, negative 1, switch them around. 1, 0, 2, 1, 4, 2. Okay, you switch the x and the y. That's really all you do. And then you plot. So x is at 1/4, and it goes down negative 2. X is at 1/2, and it goes down negative 1. X is at 1, 0, 2, 1, 4, 2. And we know that if I plug in 3, I get 8, so I can also go there, so 8, 3. Here is my log base 2 of x function. Okay. My domain, my x's are restricted. I cannot have any x less than 0. I actually can't even have 0. All of my x's must be greater than 0. Okay. But my range, however, is all real numbers. I can have any y value come out of that. So it's exactly backwards from an exponential function. It's like the inverse. It's exactly the opposite, okay? So as x goes to blank, f of x goes to infinity. Well, as x goes to infinity, f of x goes to infinity. And then as x approaches what? F of x approaches negative infinity. Well, as x approaches 0, f of x approaches negative infinity. Okay? My x-intercept is 1, 0. My asymptote, instead of y equals 0 this time, it's x equals 0. Okay? Let's do another one. Let's do number 2. Okay. Again, we need the inverse first, so this is 1/3 to the x, which then we will change to log base 1/3 of x. Okay? So your steps should be use inverse, table of values, switch x and y, and then plot. Okay, and I can make you a cheat sheet if you would like. Okay, -2, -1, 0, 1, and 2. I know these are going to end up being my y values, so I'm just going to go ahead and put them over here anyway. Okay, if I plug in -2 to 1/3 to the x power, let's just see what happens. I'm pretty sure I'm going to get 9, but just so you can see, I'm going to get 9, because 3 to the negative 2 power is 1/9, so 1/3 to the negative 2 power is 9. If I plug in negative 1, I get 3. 0, I get 1. 1, I get 1/3. 2, I get 1/9. Okay, and then we just swap the x and the y. And we plot. So 9, negative 2. 3, negative 1. 1, 0. 1/3, 1. 1/9, 2. So this one is actually going up. Whoa, way off. Up. This is why I use pencil, people. Mine is not perfect at all. Okay, it's the opposite of the one above it. Okay, so my domain, I still cannot have anything less than 0 for x. I must have everything greater than 0. Okay, my range is again all real numbers. As x goes to blank, f of x goes to goes to infinity. So as x goes to 0, in fact, my function goes to infinity. And as x goes to blank, f of x goes to negative infinity, while as x gets bigger, my function gets smaller. My x-intercept is still the same, 1, 0, and my asymptote is still the same, it's still x equals 0. Okay, let's do one more, just so we know we've got this down. I know this is turning into a long video, but trust me, you'll be glad we did some together. So we're going to do 3, and then we'll do 4, 5, and 6 in class if we have time. Okay, so this time we're going to use 3 different things. We're going to use the inverse, so 4 to the x is my inverse. Then we're going to use our regular log base 4 of x. And then this is actually a shift to the right, because we know that whenever I plug in something on the inside of a function, it shifts it to the right or left. Since it's -1, it's to the right. So then we're going to go there. And I'll show you what we do there. Okay? So we're still going to use the same table of values we've been using. -2, -1, 0, 1, and 2. If I plug in -2, I get 1/16, which is 0.06. If I plug in -1, I get 1/4, which is 0.25. If I plug in 0, I get 1. If I plug in 1, I get 4, 2, 16. All right, now we're going to switch these for our inverse, our regular old log function. So these are now my y values. These are now my x values. And now, since I'm shifting to the right, I'm actually going to add 1 to all of my x values. My y values will stay the same. I'm going to add 1 to all my y value, or all my x values. So instead of 0.06, this is now 1.06, 1.25, 2, 5, and 17. Okay. So now I just plot these points here. So 1.06, -2, 1.25, -1, 2, 0, 5, 1, and then 17, 2 is not even on here. So it's going to look like this. And I'm approaching 1. My asymptote is x equals 1, in fact. Okay. And my x-intercept is 2, 0. My domain, all of my numbers are bigger than 1. My range is still all real numbers. I can cover any y value I want. As x goes to blank, my function gets bigger, so as x goes to infinity. And then as x approaches 1, my function gets smaller. All right, and that's graphing, and we'll spend a lot of time in class working on graphing to make sure we have a very solid understanding of how to do inverses, how to plot points, plug things in, all that fun stuff. All right.